Tech in 5.
Ever wondered how top tech companies evaluate coding skills in interviews? Mastering coding challenges is your key to securing that dream tech job. Curious about the royal line of succession? Let's find out through code. Today, we're diving into a fascinating realm where history and code intersect. The British royal succession, a blend of tradition and law, is dictated by descent, legitimacy, religion, and common law. It's a system that has evolved over centuries, shaped by statutes and conventions. Let's explore this through our coding challenge. In our challenge today, you're given a royal family tree as a list of parent-child pairs. Your task? Write a function to find where a family member stands in the line of succession. Here's the catch: the current monarch and their direct ancestors, including past kings or queens, don't count in the succession line. With a list, the reigning monarch's name, and a family member as the parameters, can you calculate the correct succession rank? Now, let's have a quick look at how the royal succession line works, as shown on this family tree. Succession to the throne follows a specific order, starting with the monarch's eldest child, then their descendants, before moving to the monarch's next child and their descendants, and so on. For example, if a monarch's eldest child has 3 children, these grandchildren would be next in line after their parent, before the monarch's second child. It's a simple yet strict hierarchy, where the rank is determined by birth order and direct descent. Considering the nature of our royal succession challenge, you might think depth-first search, DFS, is ideally suited for this task. And you're absolutely right. DFS excels in navigating hierarchical structures like family trees, allowing us to systematically trace the line of succession in a logical and efficient manner. In tackling our royal succession task, we start by constructing a family tree from the parent-child pairs. Each person in the family becomes a node, and their relationships form the branches of this tree. Let's take a look at the Python code for building the family tree into a data structure. For this part, the function buildFamilyTree takes a list pairs. First, we iterate over each parent-child pair in the list. For each pair, we check if the parent is already a key in family tree. If not, we add it and initialize its value as an empty list. We then append the child to the parent's list in family tree. While building the family tree, there's a common misstep that's easy to overlook: ensuring that every child is also included in the tree, even if they don't have children. This step is crucial to make our tree a complete and accurate model. To identify which members are not part of the succession line, we mark the current monarch and all their direct ancestors. In our approach, we first create a child-to-parent map. This map is a dictionary, where each key is a child, and the value is their parent. This direct mapping allows us to quickly identify the parent of any member. Then, starting with the current monarch, we'll use a loop to work our way up their family tree, continuously looking up each member's parent. Every parent we find is added to our excluded_members set. This process continues until we reach the top of the tree, where family members no longer have recorded parents. It's a straightforward, iterative approach that prepares our family tree for the next step, calculating the succession rank using depth-first search. Here's how it works. In our algorithm, we begin by identifying the roots of the family tree. These are the members who don't have a parent listed. Once we find a root, we start our depth-first search, DFS. This process involves visiting each member in the family tree, starting from the root, and moving down to the children, grandchildren, and so on. During our DFS, if we come across a family member who isn't part of the excluded set, which includes the current monarch and their direct ancestors, we increment our succession rank counter. The search continues deeper into the tree, exploring each branch by visiting the children of every member. However, as soon as we find the family member we're looking for, we stop the DFS right there. This method ensures we accurately determine where a member stands in the line of succession. Now that we've prepared all the components, let's dive into how our calculate succession rank function brings them together to solve the royal succession challenge. Firstly, we construct the family tree in the child-parent map using the given parent-child pairs. Next, we utilize the child-parent map to trace and identify the ancestors of the current monarch. We mark these ancestors, including the monarch themselves, as excluded members. Finally, with our family tree and list of excluded members ready, we initiate our depth-first search. This search begins from the root members of the family tree, systematically traversing through each branch. This solution involves building a family tree, a child-parent map, marking excluded members, and performing a depth-first search. It has O of n time and space complexity. Got a different solution? Feel free to share your ideas in the comments.
Stay tuned for more videos on Tech in 5.